So this question asks us to find the arc length of a polar curve where r is equal to 6 cos theta from theta equals pi over 2 to pi. So we know that our formula for the arc length, in this case, would basically be equal to the integral from a to b of the square root of r squared plus we're going to be taking the derivative of r with respect to theta squared, right? So this is going to be taking the integral of this entire thing of whatever's inside this square root. So first, let's find dr over d theta. So remember, dr over d theta it's going to be fairly easy because we have 6 cos theta, and the derivative of 6 cos theta is just going to be negative 6 sine theta, right? So that's our first part. Now let's plug in what we know and solve the actual integral. So I'm using green here, and therefore going to be equal to the integral. Remember, our a is going to be pi over 2, and our b is going to be pi. And we're going to be taking the square root of r squared. Remember, r in this case is 6 cos theta. So 6 cos, plus our dr over d theta squared is going to be negative 6 sine theta squared. And we're taking the derivative of this. Keep simplifying this. We will figure out that this will be simplified into the square root of, remember, if I have something happening like this, right? I have 6 cos square, it should become 36 cos square theta, like that, right? And then this is going to be, again, negative 6 squared is 36 sine squared theta, d theta. What's going to happen next is I can actually do some factoring, right? Don't forget plus sign there. And when we do our factoring, it's going to be pi over 2 to pi. We're just going to have our square root. We can take out a 36 as it's common, and we can have cos square theta plus sine square theta. And we have a beautiful trig identity here. Remember a trig identity, the Pythagorean identity, where cos square theta plus sine square theta equals 1. So we can apply this to here, right? So we can apply the Pythagorean identity to here. So it's going to be equal to pi over 2 from pi over 2 to pi for the square root of just 36 times 1, right? D theta. And we know that that's going to be equal to 6. And the integral of just 6 is just 6 theta in this specific case. It's going to be pi over 2 to pi for 6 theta. Sorry, that's the wrong format. Once you take the integral, you have to write it like this. It's going to be 6 theta, and we're going to be plugging in pi over 2, pi over here, okay? And our final step, which is once we plug everything in, we should get our final answer, which is going to be 6 times pi subtract 6 times pi over 2. Now, once we multiply by 2 on both sides, so it's going to be 12 pi over 2 minus 6 pi over 2. And we're going to be ending up with 6 pi over 2. So therefore, the final answer to this problem is 6 pi over 2. Therefore, the arc length of the polar curve in this case would be 6 pi over 2.